simplifying radicals. So square root of 50, drawing our factor tree, becomes 25 and 2, which is 5 and 5. Remember, there's a 2 assumed here. So we have two 5s, that means one of them comes out. But we have nothing to pair this 2 with, so it stays under the radical. If I have square root of 192, that's 64 and 3, or 8 and 8. 2 8s, 1 comes out, nothing to pair the 3 with, so it stays inside. Square root of 42 is 6 and 7, which is 2 and 3. There's nothing to pair any of these with. So nothing comes out and it all stays under the square root, meaning it cannot be simplified. Cube root of 108 is the same thing as 9 and 12, 3 and 3, 3 and 4. 3 3s means 1 comes out. Nothing to pair the 4 with, so it stays inside. Negative 4th root of 80. Well, that's 8 times 10, which is 2 times 4, which is 2 times 2, 2 times 5. I have 4 2s. So the negative's out front, 1 2 comes out. Nothing to pair the 5 with, so it stays under the 4th root. So now let's throw variables into the mix too, instead of just numbers. So say for example I have the square root of 36x to the 5th. There's a couple ways you can think about this. We already know the square root of 36 is 6, and now we need to know what do we do with these x's. You can think about it as how many pairs of 2 can I make out of 5? Well, I can make 2 pairs, so 2 comes out, but that doesn't use all of them. There's still 1 left over, because 2 pairs of 2 would be 4, so the last one stays in the square root. Another way of thinking about this is I could rewrite this to be 1, 2, 3, 4, 5 x's. So here's 2, here's 2. So kind of like with our factor tree, 1, 2 is what we can pull out, leaving this guy inside. So you can make a factor tree of variables as well. We'll show this method once more with the next problem. So if I have square root of 32, m to the 5th, n to the 4th, this is the same thing as if we built a factor tree. 2 times 2 times 2 times 2 times 2 is what 32 would be if we completely factor treed it out. We'd have 5 m's and 4 n's. So here's a pair of 2, here's a pair of 2. So I have 2 2's pulled out front, leaving 1 2 inside. Here's a pair of 2, here's a pair of 2, leaving 1 inside. Here's a pair of 2, here's a pair of 2. Simplifying this, 2 times 2 is 4, m times m is m squared, n times n is n squared, square root of 2m. Trying another example. So say for example that I'm given the cube root of negative 125 k to the 3rd p to the 7th. This is negative 5 times negative 5 times negative 5. So I can pull one negative 5 out. That takes out the entire number. 3k's takes 3 to pull 1 out, so 1 gets to come out. Uses all of them. How many sets of 3's can I make out of 7? I can make 2 sets that will use 6 of them, but it leaves 1p inside. say for example, I have negative fourth root of 162x to the 7th y to the 8th. Well, 162 is the same thing as 81 times 2, 9 times 9, 3 times 3, 3 times 3. So I have 4 3's, so 1 comes out. The 2 stays inside because there's nothing to pair with. How many groups of 4 can I make out of 7? I can make 1 group, but that leaves 3 x's left inside, behind. How many groups of 4 can I make out of 8 things? I can make 2 groups of 4. Sixth root of 7 squared. This is the same thing as 7 to the 2/6 power, which is 7 to the 1/3, or the cube root of 7. They're equivalent. Last example, I know this is a lot of them, just to give you kind of an idea of what you can run into trying to get a wide spectrum of problems. We could take this and say 4 to the 4/6 is the power, which simplifies to 2/3, which is the same thing as the cube root of y squared.